All right, to just get a feel of the room, how many of you are already React developers? I'm assuming everybody. All right, sounds like almost the whole room. And how many of you are already using React Server Components? A fewer hands. Okay. All right. Anybody new to React here who doesn't? All right, one. Okay, a few. Great. Okay. So in this talk, I'm going to be talking about this concept of server components. And I'm going to be using Next.js examples because they work kind of hand in hand with the React team. And they're fully compatible in their production with React Server Components. So it's easier to explain it. Are there any Next.js users as well? Oh, quite a bit. OK. So yeah, let's get rolling on this. So traditionally, we have the client and the server model. And let's kind of get some definitions out of the way in case people aren't aware of what React Server Components are. Typically, what we call as a client in our web-based applications is the user's browser, right? So this is where you see the user interface, you see the interactions happening out there, and you can respond and do all your button clicks. So that's the client. Now, the client user interface is what you call as your JavaScript bundle. That's where all of your front-end code exists. Now, the server is typically a computer in a data center. It could live anywhere in the world, and it stores your application code. So this is where the client is going to send some requests to, and the server does some computation, and we get the response back. So these are the traditional definitions of what a client is and what a server is. Now, so far, up until React 18 was officially released, the way we wrote React code involved having all of your components in the client code within your JavaScript bundle. So anytime you had a component, it would be all front-end code put in the JavaScript bundle. Now, with the release of React 18, in the beta release, they had what's called a React Server Component, where they kind of switched up how things are working now. We have more options. Now, if you were using a production-grade framework like Next.js, there are plenty of frameworks. There's Next.js, Remix. Any Remix users? One. Wow. All right. Remix is also an equally popular framework like Next.js, and they are a production-grade framework as well. So when you use framework like Next.js now, what they've done is they've made the client components a little bit better. So instead of completely doing all the rendering at the time of the time when the user interacts with it, instead they pre-render the client components on the server now, and then hydrate it on the client, which means it's a little bit faster and hopefully performs better. So the client components on Next.js are no longer completely just waiting to be rendered at the time the user sees the bundle. So they're pre-rendered on the server. Now, the new concept of server components takes it to a new level. So the server component is one that is completely rendered on the server. Now, all of this code that you write within your React Server component is going to be not a part of the JavaScript bundle anymore. So it is all a part of your server in a separate environment. Now, to run the server components, which means then you are going to be using a framework typically. And what's interesting is like framework like Next.js are early adopters of the React Server components. I believe a part of that is also because the React core team and the Next.js Versal team work hand in hand. So Next.js has some of these latest features of React implemented early on in comparison to other frameworks, but they catch up too. So React Server Components, I guess in a few months, would be something you'll find in many other frameworks as well, outside of Next.js, if that's concerning to you. All right, now what does a React Server component look like, right? So what does it look like? Now, if you see this code here, are you able to see some of that, a little bit of that even in the back? Gotcha. All right. So you see here that this is a React component. I have a component called cake, and it's rendering something. We have some divs, and we are rendering some item info, which is basically, I guess, the pie name and an ID. Now, before the render, before the return, you see that we're actually fetching something. So within our React server component, we're now doing a fetch. So the fetch is going to say, hey, get me all these pies with a category. I have a query parameter. And it's actually an async await call. So before the introduction of React server components, we've never seen code like this before, where you have a component, and within that component, it is an async component, and you're fetching right there, and you're waiting for the results and then rendering the results. So this is sort of new if you've never seen a React server component before. Now, imagine all of this can also do not just server API fetching. You can do direct database queries now inside your component. So you can directly access the database, do a read or a write from within your server component. Kind of looks funky. And if you remember the PHP days, this is sort of probably for those of you who've done PHP programming, this is where we're kind of moving to the server, back to the server. Because all these years, we've been doing a lot of client code with web apps. And now we're kind of at the point where we're like, OK, I guess we're learning from the past, learning from our mistakes, and maybe it makes sense to move some of this code to the server instead of putting everything on the client. So what this essentially does in this code snippet is it makes a server API call, fetches it, and renders all of this. And none of this will be part of your client-side JavaScript bundle. This is going to live on the server entirely. Now, server components, like we talked about, will not be sent to the browser, so they cannot use interactive APIs. So we use all these hooks in React, right? Like useState, useReducer, all sorts of hooks. So none of those can be used within a React server component, which means you cannot have interactions like that. You can't, if you want to hold on to a state, if you want to use a reducer, or if you want to use something like the useEffect hook, those will be client components, because we're not getting done with client components. Client components are going to be living and thriving, and you do the same thing. React server components are pretty much just an addition, where you probably use it for something like data fetching. Now, what does a React tree look like now? So we all know that React is a bunch of components, and we have a component-based model with a component tree, right? Now, you can interleave a client and a server component wherever you want within the tree. So you could have components which are client and server within. So here the pink represents the server components in this example, and the greens represent the client components. And you have the app on the very top, which is the root of your application. And this is just an example. You can switch it up however you want. The idea is to show you that you can interleave client and server components as you like. In the ideal world, you would have client components as leaves to the tree, like you see here, and you would have the server components basically on the top level layers. But that's not necessarily required. But it would be giving you the best performance if you have client components towards the leaf of your tree. So now, as React architects or developers, you have one more thing to think about, right? When you're developing your applications or architecting your applications, you have to figure out which of these are good candidates to be on the server, and which of these are good candidates to just remain on the client. Let's take another example here. So I can show you the app in a little bit. I have a pie shop called Bethany's Pie Shop. Now, Bethany's Pie Shop is going to have a shop menu where it's going to display menu items. It's going to show different coffee and pies that we can shop. And it's a typical app that is going to let you add some items to the cart and things like that. Now, how would we sort of arrange that or design that application? So let's say we have a nav bar, a search bar, a menu, and then we're going to have a profile section, some buttons, right? So typically, your nav bar is not really going to change as much. Your profile section not really going to change, and the menu bar. So all of these can be server components. And now when you have interaction and you want to hold on to state, those can become client components. So again, the green represents the client, and the pink represents the server components. So the mindset and the thinking and design of how you've done React changes now. because now you have to think about how you want to compose these components and how do you want your component tree to look like. So a guideline of when do I use a client component versus a server component. It's not rocket science. It's pretty straightforward. You would use a client component if you use any React hook. Like we talked about the use state, the use effect, reducer, or any other hooks that your libraries come with, that would be straightforward a client component. If you have interactivity and event handlers, you probably use a client component. And if you have custom hooks that you create that depend on state and effects, that would also be a client component. Now, server component, where they do well is for fetching data and mutating data. So if you have that situation, like we talked about here, where we have a shop and we're like fetching some menu items, a server component would be an ideal candidate. Another good thing about server component is now that we're back to the server, we can store sensitive information in the server. API keys, tokens, if you have things like that in your application, which we will, they can be stored in your server component. And the idea behind this is you're essentially accessing all these backend resources directly. You are right there, and you don't need to make these round-trip network calls, which are far away. Instead, you're right on the server. And anytime you see there are large dependencies, and there's not really much to hold on to in terms of user interactivity, it's recommended to use a server component. All right. I'm going to show some example here real quick and switch away from my PowerPoint slide to see if that sort of makes sense. All right. So this is Bethany's Pie Shop here. And we have some static data that we're displaying, and we have a shop menu. Now, clicking on these are going to show me some seasonal pies. I'm going to show some fruit pies. And you can see some data fetching happening right there, right? Now, this app is built with React and Next.js 14. And it's just a demo application. So you see here, you can add to cart and go view what's in the cart. Now, what I've done here is I have all of these pages fetching data designed as server components. And things like buttons and clicks are going to be client components. So we can take a look at what this really looks like in code. All right, so Next.js follows what's called the folder-based model. So right here, I have a page. And it's very similar to what we just saw in my code snippet. So my component here is an async component called seasonal. It's going to display seasonal pies. And you see here that we have the async await fetch. I'm fetching the API call, and I'm waiting for the response. I'm saying, hey, give me all the pies in your menu which are seasonal. And I wait for the response and then render the pie information. And this is typically what it looks like when you have a server component that has no client interaction. Instead, I'm merely fetching some data and displaying it. You'd also notice there is a revalidate out there that says revalidate equals 300. We'll get to that in a little bit, but what it essentially does is it's going to refetch that data in case it's dynamic every 300 seconds. We'll probably get to that in a little bit. So the idea is that now I've structured all these pages to be server components. I have another page as an example I can show. There's one here again, the all pages. This is going to fetch all of my pies. It's pretty much the same code, and I'm using the fetch API here. Now, Next.js has a wrapper around the native web fetch. So that's what this fetch is. And it's pretty straightforward and supports different types of fetching. You could do a static data fetching. You could do a dynamic data fetching. Or like we saw earlier, you could do a fetching which revalidates every few seconds. And we'll get there in a bit. At this point, I can also show you how we've arranged components which are not server components. So out here, I have I believe, a UI. And you can see here what a client component looks like. Client components now need a directive called use client on the very top of your file. And that's what tells the app that it is a client component. So now I have other things like use state, some button clicking. I'm handling the state of that component. And if I did not add that use client directive on the very top, it's going to error out. So you don't need to worry about not adding it. Even if you don't, you're going to see a runtime error. So now we have to divide our components, and anytime you have a client component, you just need to add that little directive that says use client. All right, so let's go back to our slides here, and we talk a little bit about the data fetching as well. All right, why are we moving to the server components now? The idea is obvious. We're moving this data fetching layer closer to the server, closer onto the server, and closer to the database. So in theory, the hope is that things are going to be faster, computations are going to be faster, your data fetching, data mutations are all going to be faster. And the initial page load is now going to be faster. Also, the overall client-side JavaScript bundle is going to, in theory, shrink, right? Now, when you're going to utilize server components, the JavaScript bundle is going to reduce. And overall, when you're going to start putting all these dependencies on the server, we're going to see an increased performance, and the user is going to see that things are moving faster. And that's the idea behind the shift towards React server components. You may ask, why didn't they think about this earlier? But technologies evolve, and we learn from mistakes. And now where we're at, we realize that React server components is going to be the way forward with React development. There's numerous other benefits as well. Like we talked about the security aspect. We can now have an option to put all these tokens and keys on the server. There is also this concept called streaming. What's going to happen with React Server Components is as and when the components are ready, they're going to start streaming in. So the rest of the UI is not going to be frozen, and we're just not going to be staring at a loading screen. Instead, we're going to have these UI split into chunks, and they're going to stream as and when things are ready. You may have the nav bar, the profile bar, and you may have like a few things on the screen already while you're waiting for the other content to come in. The next benefit is the idea of caching. Now that we're utilizing the server, we can utilize a server cache. So things are going to start getting faster because we can now store all of the data that we just fetched onto the server cache. And finally, there's studying and some work done to realize that the SEO is also going to benefit from this. So because the rendered HTML can be used by the search engine, we're going to have a good amount of search engine optimization benefits through these React server components. Now, we talked about the fetch API that we just saw with Next.js. So let's go ahead and deep dive into what exactly that looks like and what are some options that Next.js is providing. Now, the first kind of data fetching that you can do with the Fetch API is static data fetching. I would use something like static data fetching for your web apps that have static content that doesn't change much, like a conference page or a blog page, things that don't need like dynamic data like a shopping cart, right? So this data is then going to be fetched from the server and cached on the Next.js data cache. Now, static generation, as we talked about, is useful anytime your web app doesn't have much content changes. And by default, Next.js does use the static data fetching. So if you don't give an option, it's going to do static data fetching automatically. The example that we saw here so far, where you call the Fetch API with a URL, this would do data fetching and store it in the Next.js cache. Now, what is this Next.js data cache? It has a built-in cache, and this data cache for Next.js stays on the server, and it's going to persist all the results on this data cache. It will scale automatically, and it will be shared across multiple regions. Now, this data cache is unique to Next.js, and the other frameworks, if you choose to use, would have their own mechanisms for caching React server components. Now, what is the benefit of doing something like that? your data is going to be persistent across multiple requests and multiple deployments. Now, the shopping page that we just saw, if I did static data fetching, it's going to put all that data in the Next.js cache, and every single time I go to that page, it's just going to pull that data for those seasonal pies from the data cache instead of making the complete network request. It's going to minimize your load and requests made to the data source, and obviously improve the performance as a result of using that cache. This is what the flow looks like. So this is taken from the Next.js documentation. And if you'd like, after the talk too, you can go and explore that documentation. I've added a link there. They have some explanation of how this data cache works behind the scenes. I don't want to dive into details too much during the talk, but you're welcome to go look at it. The idea is that you would hit the data source first, put the data back in the cache, and every single time you access that page again, you're going to pull the data from a data cache. And this is where we're going to talk about another type of caching, which is an in-memory cache, which is called memoization. For those of you who are React developers, they already know about memoization because that is not a Next.js feature. That is a React feature that comes just out of the box. Memoization in React happens all the time, and it works the same way, except it does not persist across deployments. Instead, it persists across a single render pass. So let's take a look at how that would work. The difference between a data cache and a memoization in React is that data cache that we're talking about in terms of Next.js will be persistent across deployments. So every single time you deploy that app and go back to that page, it would always pull the information from the data cache. Whereas memoization is temporary. It is only for that particular render. So let's say I call the same fetch API on a seasonal pies page and also the all pies page. Then it's going to use the request memoization and pull that data from the in-memory memoization that was done. And that would only work during one render. So when I redeploy, it's going to refetch. And there's really not a lot you can do about memoization other than just know what it is, because these are things that happen behind the scenes, and it's just good to know that that's happening. With memoization, we reduce the number of duplicate requests within the same render pass that have crossed the network boundary. And in terms of code, this is what it looks like and what I mean. Let's say you have a page where you call a function called getData. The very first time, that data is not in the cache, so it will actually go fetch it. And the future is where you call getData, it is simply going to have everything in that memoized, and it'll fetch it from there. So you don't need to worry about calling all of these fetch calls multiple times across multiple components at all, because it's not going to add any load to your network request. Instead, it's simply just going to pull it from the in-memory. That's what the idea is. All right. Now, we saw an example earlier where there was a revalidation parameter. So that is an idea where we do static data fetching, but with revalidation. This is the most used feature of the fetch API, where if you have data that changes, but not as frequently, you don't need dynamic data, but you just want it to refresh every few minutes, every few hours, then you could use this revalidation. So it would incrementally revalidate the cache every few minutes, and you can tell how often that needs to be done. So the data is fetched and cached initially, and each request will reuse the cache until it reaches the time interval that you tell it. After the time interval, Next.js will revalidate the data, and then it'll invalidate the previous cache. This is what it would look like, where it would, after the time interval is reached, it would invalidate all of that, and then update the cache with the new data. And once the new data is available, the stale data that you see as a user will be refreshed, and you'll see the new data. All right. If you go around the same Next.js documentation on the data cache, you'll see their explanation on how this revalidation works behind the scenes. We just talked about it. So the idea is that we first go to the data source, and then we keep pulling the data from the cache, And once you get that timer running, and let's say you reach 5 minutes, it's going to go pull the new data, update the cache, and then finally update the UI. Pretty straightforward. With this sort of mechanism, what happens is after the initial request, it's always going to be coming from the cache, so you'll see that improved performance. And behind the scenes is where this re-triggering is going to happen. So as a user, you're just still going to see the old data, and that would only get refreshed if there's any new data that's available. If that call fails for some reason behind the scenes and there's some errors, it won't impact the user. It's still going to show the stale data. Now, the next type of data fetching from the Fetch API is the server-side rendering, which is like a complete server-side rendering, also known as the dynamic data fetching. With dynamic data fetching, there's going to be no cache. You're not going to use the Next.js cache anymore. You don't have to. And you don't need to use any sort of revalidation. Instead, every single time you make that call, it's going to pull the fresh data from the server or the database or wherever your data source is. This content is rendered on the server for each user at the time of the request. A benefit of a truly dynamic data fetching or the server-side rendering is that it'll be real-time data. So this would be things like, let's say you have an app like Amazon and you want cart updates. That would be real-time data. We don't want to mess with that. And we want that updated every single time the user hits that page. And we have user-specific content, so we can share all of this across a cache, across deployments. And also, we need the request. It's a request time information. So anytime you have dynamic content, absolutely use a server-side rendering, and you don't need to use the Next.js cache at all. And there, you eliminate the cache, and you directly interact with your server. All right. Now, what are some best practices around this? Now, we earlier saw that component tree with React, and we saw how the leaves were really part of the component tree were mostly client components. Typically, I like to design my React components in such a way, if possible. It's not required. So as long as you have most of your leaves as client components and all the higher level components as server components, you're going to have a good performance. Like this picture we talked about, where all the client components are sort of arranged in the bottom. And server components, there's a small catch here. They cannot directly be imported. So server components cannot be directly be imported within a client component, which is why the client component is part of the leaf. But of course, there is a workaround, and we'll see how that will work. So let's say you have a client component. It does something. It has a use state, and so on. And you're importing this server component in it and rendering it. So this code will throw an error, because you can't do this sort of direct import of a server component within a client component. And it would throw a runtime error, or even in your VS Code, as you start typing it, it might error out. So to kind of overcome this and have a workaround, what you do instead is you pass that server component to the client component as a prop, as a child prop. If you ever had to put the child component on the top and the server component in the bottom, this is how you would work around it. So let's see what that looks like. So we have this page, and you see there's a client component and a server component, and we wrap the server component inside the client component as a child, basically. So when you look at the child component itself, I pass props to it, and that prop is basically my server component. So that's something to think about, and again, you don't need to stress too much about this, because if you accidentally do import a server component within a client component, it's going to error out. So you would know right away that something got messed up there. Now here's where it gets tricky. Now we're still in the early stages of React server components. Different frameworks are evolving so rapidly. Next.js has full support for React server components in production. It's for a while now. Since Next.js 13, they've had support for it. And today, with Next.js, if you're using the app router, so they have two routers, the app and the pages router. If you're using the app router, by default, all of the components you create would be created as a server component unless you specify otherwise. So they're going to assume it's a server component until you say, please use client. So what is going to happen if a library doesn't use server components? We as React developers utilize so many third-party libraries, and not all of them are going to be updated, upgraded, ready for React server components, and so on. So as of now, what you would do is convert the entire library as a client component if they don't have support for React server components. So as a few months ago, I knew that the material UI wasn't really supporting React server components yet. I don't know if they've changed or a new version has come. Things keep changing, I don't know. But what I did for one of my clients was had to convert all of that material UI code to client components. And the way that works is you have the server component on the very top, and you're going to have to wrap your library around a client component and add that use client directive. And that's what's going to convert that whole library into a client component. Again, this is going to be a workaround until we have support on a broad scale for React server components. I do think this is sort of the future, and libraries are probably going to play catch up. There may be some that are never going to have support for it for a long time. There may be some that already have it. So it's just, the evolving nature of this space. And with that, I'd like to conclude the talk.